Test, 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 test. Hey, that sounds way better. There we go. All right, let's get this headset off and stop hearing myself echo in the background. Cool. Well, if you're going to screw up, let's screw it up big, right? Let me back out of this real quick. Now that you can all hear me clearly and I don't sound like a robot. And for those of you in chat, thank you very much for all of the letting me know that there's been problems nonstop. But all right, let's kick this off. So I'm going to start by drawing my tooling ball. Obviously, the moment I started talking about an LS head, a lot of you guys got excited. So I can only imagine what you're waiting to see on my end. But as you're seeing me do here is I've just created a circle with a couple of rectangles. For those of you that know me, you strongly believe that I don't like to do anything real crazy or precise at first. We can always come back and modify things. Again, maybe our overall length here. Go ahead and go off the arc. And let's make this, 1 inch. Actually, we're going to have to make that a little smaller. So let's say we're working with a 1/2 inch ball, 3/4 from the bottom. Drag this guy in. We're going to go ahead and drag this whole guy up. Again, making these changes pretty quick here. So I'm not going to spend a ton of time on dimensioning this fully out. As you guys can see, you could continue to dimension this as much as possible. But it would be very important to have certain dimensions. In this case, distance from the flange to the center of your ball. This is very important when it's time to actually use something like this. So let's go ahead and get that dimension in there. So as you can see, I've now created that sketch. We're going to actually go back to our sketch and add an additional line. Maybe I won't edit this video. It'll be funny for anybody that jumps in here to watch the video that's pre-recorded. We're going to click those profiles, as I'm saying for the second time now. We're going to grab that center line of our axis, and as you guys can see, we've now spun that into our tooling ball with our little shank down here that we would use with a reamed or bored hole to align that, right? So as I pivoted to earlier is we're going to go ahead and add our joint origin. Now the joint origin is, the purpose of this is where we're going to set our work offset in most cases, so that once we get our part positioned in our machine, we can actually use center. So if you coaxial or use your probe to pick up center and then set your Z height. But let's go ahead and save this. Again, this is our tooling ball version 2.0 due to my terrible stream starting. And now that we have that saved, let's go back to the old LS head that I was talking about. So you guys can see the LS head, right? And I sound good. Just want to make sure. Give you guys a couple seconds. And crickets. There we go. Awesome. Thanks, Dylan. So again, as I was saying, long before I screwed this completely up, is awesome. In the case of this head, this may be a casting, or we may have actually machined one of the faces on this part, right? So I need to place that tooling ball usually after I've machined something, right? Maybe I'm starting here on what is the exhaust flange side of this LS head, and I'm going to go ahead and pop open my design area, and I'm going to take that tooling ball version 2.0, and I'm going to drag and drop it in. Now, based on normal machining in a 3-axis environment, again, we need some type of location or some way to mark our actual tooling ball and place it on our part. So I'm going to go in and we're going to actually do a joint. And this makes it very easy to set this tooling ball on to our face or our locator hole. In this case, I'm going to use this hole here. We need to flip it to the opposite. Yes, I know that shank size would have to match the same size. Guys, you would put more detail into this. This is just to give you an idea or a different thought process. So as I got asked quite a few times recently about setting something up like this is, if we've already machined this flange and we had to flip this part up to set valves, go in, machine our actual cam or our rockers, anything from one face to another face or another setup on a part, I have that ability when utilizing something as such. So let's get these setups out of the way. And how I use this is actually relatively straightforward. I'm going to go in and create that setup. Give it a second here to fire up. We are streaming live as everything is going on. For those of you that we've all automatically jumped to a ton more viewers, you guys missed the show earlier when I completely forgot to change my screens over so you could see what I'm doing. But from here, we're going to do our normal. We're going to set our Z and our X. Again, maybe my Z is off this face. We're doing the first setup. Again, my Fusion is lagging quite a bit. Hopefully my audio didn't go out. And from here, I like my X-axis, but this is where we're going to define with a selected point. The whole point of this joint origin is nothing more to always be that location of center of the sphere. So if we're using, like I said, coaxial indicator, probing system, anything as such, I can actually pick up the center of the sphere to work off of, right? So more commonly, a lot of you guys, when you make like 3-axis soft jaws, you may put a counter bore in that jaw because later you can pick up the center of the jaw versus the part. The idea is still the same here, right? So again, based on this, we're just going to say, you know, the stock, maybe we'll just say the whole head is the stock, and the part is also just going to be that head. So everything turns off automatically and hides itself in the background. Now, if you guys didn't know, you could actually do some pretty cool things with your settings here. Is I highly recommend syncing your active setup with the different views, because as you saw, the only things that are showing up is the models and fixtures that I wanted to use. So if I wanted to actually say that tooling ball was a part of my fixture, which I'm going to duplicate my setup, and this was one that I completely forgot about until recently, hit the S key. You can set whatever you want in your own menu for creating different shortcuts in the manufacturer world. I'm going to right click in this case, and we're going to go ahead and say duplicate. And then let's edit this, right? So if I was moving on to my second setup, maybe my Z, as you guys didn't see until you told me, is off this face this time. Again, now my Z axis is up. Maybe this time I am going to say now my fixture actually includes that tooling ball. Granted, I don't have to worry about collisions with that fixture, but now again, so we've auto synced to that new view. If I go back to my first setup, you'll notice that we kick around and my Z axis has changed. So at a very high level, as you guys are seeing, is that tooling ball is basically my point of reference. That's my work offset, right? So as long as I can get my tooling close to that ball to be able to pick it up, probe it, locate it in, I can actually rotate and flip this part kind of in any angle or any configuration. Now, I could always add additional tooling balls here, depending on different locations or different features after I've machined it. But trying to do 4th axis work with a 3-axis machine, this is what's going to be your best friend. Like I said before, with a sine base or a compound sine base, if you guys don't know what those are, it allows you to stack basically precision blocks to create angles to get you flat to these faces. I would highly recommend to go out and take a look at those. But now let's look at this a little differently, right? You can pick up these tooling balls for cheap. You can make your own. As I was getting into before, is I used to use just ball bearings, right? Find a ball bearing. A ball bearing is ground. It's precision round. We can do the same concept as we've done here. The only difference is when you use a ball bearing, is I like to create that ball bearing inside of Fusion with a flat. So what you're going to see me do here is, again, is we're going to create that sketch with a circle. I'm going to add a line for a flat. I do know now for reference, this actual face is going to need to be 433. And the diameter of this ball might be 625. And as you can see, we're going to add that third line in there to revolve this. So let's get that revolved now. And the concept is still the same, right? So whether or not I'm modeling something with a shank or I'm going to just use a ball bearing I have laying around, is I can now use this flat to my advantage. So before I forget, we'll go ahead and throw our joint origin again in the middle. And to see how that is going to be utilized on our part, let's go ahead and get this ball bearing saved. Is we'll go back to our LS head. And with that LS head in the design workspace again, we will insert that ball bearing. So this time you guys are seeing me do the right click insert. Going to come in again based on the origin where we drew it. And then once again, we're just going to say do a joint between center bottom. And on this actual part, I believe this hole was the 433. And as you can see, the idea is I need that ball to basically sit tangent on that edge. Now, this hole does need to be pretty precise for this ball to take that same effect. But the idea is still the same, right? Is I have that ability to use a ball or a tooling ball for fancy means to set that point where I can pick that up in space no matter what we're doing with that part, right? So maybe let me go ahead and use the old look at function. I'm looking down on the part here, but then later we machine it from looking here. And then lastly, we may actually say look at, and maybe it's this face here, right? So as that part is rotating around rotisserie style, is I have that ability to put it in a position manually and then go in and locate off of that. So with that, that kind of wraps up this video. I know this is kind of a quick one. I try to keep these Workflow Wednesday videos down short for you guys. If you guys have any questions on this, or if you want to see some different versions of this, or you want to see how I would model a cosine base that allows, or compound sine base that allows you to manually set these angles, this is the way I've always done it. This is the way that's worked really good for my manufacturing process. As always, guys, have a great rest of your day. I do need to remember to come back and edit this video later. But with that, go out and get the day done.